Hi, and welcome to our today's webinar brought to you by StarWind with guest speaker Lucas Mirian from IDC Research, hyper-converged infrastructure and edge deployments. Lucas, the floor is yours.
Thanks, Max. So my agenda for today, I'm going to talk about global infrastructure investments and how they map to today's complex world. Then I'm going to move on to an overview of edge infrastructure, definitions and market trends. Then I'll talk about an overview of hyper-converged infrastructure, also definitions and market trends. Next, I'll talk about the intersection of HCI and Edge IT, and then I'll give some final thoughts. Next slide, please. So an IDC data center operational survey put out last May revealed that 79% of respondents were planning to deploy more IT services at edge locations. 40% plan to outsource the edge initiatives. The shift to IT service from edge locations will test an organization's ability to manage and optimize resources. As more IT resources and services are delivered from the edge locations, the ability to have the right IT skills and staff at the right locations will be limited, necessitating more reliance on intelligent infrastructure and operational technology, or partners that can make that happen. Next slide, please. So let's look at the market forecast for edge infrastructure spending on compute and storage. Currently, the market is expected to experience a 5-year combined annual growth rate of 13% to reach $21.2 billion by 2023. Conversely, core infrastructure spend will grow at just 1.1% CAGR over the same time period. Server spend, including internal storage, will grow at 13.4% CAGR, while external storage will grow at 11.2% CAGR. Driven by the market downturn due to the global pandemic, edge infrastructure saw an expansion of 5.9% growth in 2019 to 14.5% in 2020. During that same time period, core infrastructure declined by 6.3% in 2019 and 0.6% in 2020. Next slide, please. Okay, so let's look at what the edge is. First, let's recognize the core, or the central data center, which can be on-site, at a co-location facility, or it can be a cloud service. In contrast, IDC defines the edge as the vast space or intermediary between the data collecting endpoints and the core that supports all key business decision support systems. Depending on the usage, the edge can have a different meaning for each business. An edge device is typically connected to multiple endpoints to aggregate or process data. Those devices can be routers, switches, or various integrated access devices, and they provide an entry point into enterprise or cloud provider core networks. An edge is also usually distributed, meaning it has a multiple location footprint, which is generally based on the use case or architecture. An endpoint is a remote device that communicates back and forth with a network to which it is connected. It can connect either to an edge device or directly with the core, depending on the network architecture. An endpoint device can be as sophisticated as a purpose-built appliance in a remote or branch office, or as simple as a temperature sensor, a smartphone, or a video surveillance system sending data back to the core. Next slide, please. Enterprise servers, a $60 billion market, and external storage, a $28 billion market, are the bellwethers of the overall IT marketplace. As we look at both hyper-converged infrastructure and edge infrastructure hardware as subsets of the IT infrastructure marketplace, we can see they're among the fastest growing segments. HCI is expected to experience an 8% increase over the next year, while edge hardware growth is almost double that, with an expected growth rate of 15% this year. At the same time, the pace of growth of new applications being deployed in the average enterprise is tremendous and unprecedented. The typical application portfolio of the average company is expected to grow at 50% in the next 2 years, and a large portion of those applications will be cloud native or at least connected to the cloud. By 2024, 70% of new production apps are expected to be cloud native, up from 10% of all apps today. By 2023, more than 50% of new enterprise IT infrastructure will be deployed at the edge rather than within the corporate data center. That's also up from 10% today. Overall, the number of applications running within within edge environments will increase 800% between now and 2024. These are some of the elements driving HCI and edge. Next slide, please. So let's look at the edge impact to the enterprise infrastructure. There are 4 reasons edge has become popular. Number 1, latency. Real-time applications need faster response times than cloud or central data centers can provide. 2, cost. As more data is generated at edge locations, it can be expensive to transmit to a central location. 3, security and compliance. Both industry and government regulations dictate where sensitive data can be stored. And 4, resilience. The continuity of business operations if the network or cloud is unavailable. So what's the IT impact? Number 1, the need to deploy and manage a growing range of edge-based infrastructure, code, and data sets across geographically dispersed locations linked to centralized cloud resources will increase. Number 2, the monitoring and management of a rapidly expanding edge portfolio of assets and services will become a top priority. And number 3, dealing with the increasing likelihood that much of the actual underlying infrastructure is not under the corporation's ownership or control, i.e., it's owned by or operated by a network or cloud provider, will become an important new challenge. Next slide, please. Now let's talk about what hyper-converged infrastructure is. A natural evolution of converged infrastructure, or the modular deployment of data center resources, hyper-converged infrastructure is a compelling technology that has become the fastest growing segment in the enterprise storage market. The HCI market is growing at a double-digit rate. Oh, and the hyper in hyper-converged doesn't refer to super fast. It's short for hypervisor. At a very basic level, HCI involves combining compute, storage, and network elements into a single unit and then scaling it out to create a distributed system. HCI thus eliminates fiber channel components, storage arrays, and the 3-tiered SAN architecture. The building block of HCI, an HCI node, is simply an industry standard server that meets certain specifications of the HCI vendor. This is the essence of software-defined infrastructure, which abstracts the underlying hardware and networks. All the nodes are integrated by the HCI software and thus act as a single cluster. The software-defined storage element also enables automated functions, such as data reduction, backups, replication, and data migration. HCI software can also enable automated full-stack lifecycle management. HCI provides benefits similar to a cloud platform for on-prem and edge deployments. Storage is virtualized so that compute and storage services run on the same industry standard servers. It's no longer a repackaging of legacy infrastructure as it once was. Because the nodes are standard x86 servers, the cluster architecture is easily scaled out and all node and cluster resources are pooled together and act as a single resilient system. CapEx is reduced because there's no longer a need for a specialized SAN, and infrastructure scales granularly, one compute storage resource at a time. HCI also reduces OpEx as IT admins experience reduction in management and system deployment times, an increase of on-demand provisioning of resources, and the automation of data services. At the same time that HCI provides a greater level of automation and data resiliency, it can create unified management control plane for hybrid cloud and multi-cloud environment, meaning one management interface can be used to control on-prem and cloud deployments. Last but not least, I/O performance is increased through HCI due to the close proximity of storage and compute resources, as well as the ability to perform rolling upgrades to the latest flash technology. Next slide, please. So now let's look at the intersection of HCI and edge infrastructure. Edge computing is the next frontier for HCI systems. It is one of the top areas of strategic investment, especially in light of company-wide digital transformation initiatives. Edge computing enables delivery and analysis of data and resources to people and processes in a timely manner. An intelligent edge is a crucial link between the core and endpoints that provides distributed compute, data persistence, and a network aggregation layer, and it serves as an intermediary analytics engine for collected data. Where HCI and Edge meet to enable greater performance and efficiencies is in the remote office or branch office. There, HCI is used to process data pouring in from machines on manufacturing floors, smart building sensors, monitors, medical devices, routers, video surveillance cameras, and a myriad of other IoT devices. As IoT devices and 5G networks roll out in support of a growing distributed computing paradigm, developers are rushing to create and deploy new edge host applications for real-time data aggregation. That data needs to be crunched to make it useful, and an HCI platform is where that can happen right where it's being ingested, at the edge. Combined with artificial intelligence and machine learning, edge computing brings analytical computational resources into close proximity to end users and application alike. A tightly integrated HCI and edge platform can outperform a core network and cloud service. Next slide, please. Okay, so let's look at some edge use cases. When talking about edge, it's often helpful to think of it from an industry point of view. Let's take retail for an example. Edge computing systems ingest data from points of sale systems, inventory management systems, and a plethora of IoT devices. IoT devices can be as small as RFID readers, beacons that will use Wi-Fi or Bluetooth to track customers in retail stores, as well as video surveillance cameras. IDC estimates that the overall number of connected IoT devices worldwide will increase to over 35.2 billion in 2023 and will reach almost 42 billion by 2025. Video surveillance systems, for example, can consist of a network of hundreds of cameras requiring a compute system that supports the ability to conduct real-time data analytics and processing for a massive amount of data. This is particularly important for use cases that require analysis of high-definition video, where streaming massive files to the cloud will require vast amounts of bandwidth. It is possible to run the backend of all those systems in the cloud, but that's problematic. First, that's a lot of data going back and forth, so it's expensive. Secondly, what happens if there's a network interruption? Installing an HCI system in the retail store or a robo-location is a perfect edge scenario. It reduces cost and ensures business continuity. Next slide, please. So some final thoughts. First, HCI systems should offer a robust platform that can be used to implement a private cloud within a data center, and then offer intelligent software that integrates the core, edge, and hybrid cloud. As it relates to edge, HCI has proven to be a good fit for rapidly growing edge application deployments due to its high degree of automation, simplified management, and deployment capabilities. Organizations should adopt flexible IT resource delivery models that enable on-premises and network-based deployment of consumption of resources so they are closely linked to major cloud environments. And lastly, ensure that you establish security, governance, and asset management best practices to ensure optimal use of growing pool of resources deployed at the edge for new workloads. Next slide, please.
Lucas, thank you so much for joining us today and sharing great insights on this incredibly dynamic market. Now, let's take a deeper dive into one of the edge use cases, the use of HCI for video surveillance and analytics at the edge. If we look at the video surveillance workloads, we'll see they're not extremely proprietary and thus can be virtualized and easily deployed on a hyper-converged platform. As Lucas mentioned earlier, hyper-converged platforms, infrastructures, or HCIs, run storage, compute, networking, and management tasks all hosted on a set of commodity servers. Technically, HCI is just a tool, and to use this tool wisely, we need to understand its pros and cons. First, HCI undoubtedly brings ease of setup and management to the table. Second, it's more efficient in utilizing the hardware compared to a set of dedicated non-virtualized servers. Third, Compared to individual servers, HCI can be easily sized to accommodate all workloads for a given location. So we don't have to keep segregated systems and manage video and other tasks like access control or point of service separately. HCI gives you a private cloud approach where you have a resource pool available to all the workloads running in a given location, and then you just carve out the required resources for the applications. And finally, the whole system is just more resilient to failures, with everything centrally managed and architected to provide the desired resources and uptime for each individual workload. Now, while HCI is a great solution, it also has its watch-outs. First and foremost, HCI is not a panacea, so you have to employ good caution. Good thing, it's really easy to do with a proof of concept deployment, and most vendors will help you with that. Second thing, sizing the HCI to accommodate video surveillance workloads properly requires skills and experience. So this task is best offloaded to experienced teams and never overlooked. Lastly, hyper-converged infrastructures are typically scaled by adding extra nodes. While seemingly an easy concept, it adds extra cost through components and licensing you may not necessarily need. Typically, you'll have to add more storage. But in reality, you'll also have to pay for the CPUs, RAM, hypervisor, and backup licenses coming with the extra nodes. So all those expenses can be hiding in the plain sight. Good news is that this can be avoided if using the right HCI that allows you to add individual components, also known as scale up or vertical scale out. There is a sweet spot for HCI deployment in video surveillance. We can define it by 3 parameters. First, how many cameras do we need to support? Second, do we need any analytics? And third, do we need to support any other workloads? As a rule of thumb, anything less than 50 cameras can be supported with an NVR or public cloud solution. As we go up from 50 and all the way up to 250 cameras, HCI is a very good solution. You can build a fully redundant system with just 2 servers that will support 250 full HD cameras recording 24/7. As we go beyond 250 cameras, it becomes a place that's better served with traditional 3-tier architecture. That means you have a SAN, you have your dedicated networking stack, and you have your compute nodes running the VMS. As we add components like analytics, HCI becomes a better solution all the way from 1 camera and to 250 cameras. And again, if we add more workloads, let's say we want to put the VMS on the same platform, or we want to have some other proprietary application running on the same platform, HCI is the only candidate that gives you the best reliability and performance in this range. And then the numbers I have here are for today, but as we get bigger CPUs, we get more RAM and more storage, these numbers will change. So in a year or so, or even less, we'll see HCI being a dominant solution for any infrastructure up to maybe 400 or even 500 cameras. Knowing the real requirements and pain points of both integrators and users, it became much easier for us to build the right product. We worked with the leading vendors in the security space to make sure all components work together properly. The resulting product is a perfect foundation for building tailored video surveillance solutions of any complexity. Let's go over key differences that make StarWind's approach better for video surveillance. Traditional HCIs scale only by adding more nodes, which is very limiting in terms of how you add your resources. In a video surveillance use case, this would mean buying a new server every time you need a few more terabytes of storage. It's not cost efficient, and not only it adds hardware you don't need, it also brings in hypervisor, database, and backup licensing costs that drive the scaling cost even further. With StarWind, you scale your infrastructure the right way. You only add the resources you need. RAM, drives, GPUs, or NICs can be added as long as there are free slots in the existing systems. This means less complexity and cost in the long run. GPU support is another differentiator. Traditional HCIs have a limited set of nodes that can fit a GPU. With StarWind, the default platform can support up to 2 GPUs per node, and we also have a node specifically built for analytics-intensive workloads that supports up to 6 GPUs. It gives you much more flexibility in how you build your infrastructure. 99% of traditional HCIs require dedicated networking for the cluster backbone. This means you need either 1 or 2 10 or 25 gigabit switches for each cluster deployed at the edge. This adds complexity and cost, as there is more hardware to buy, manage, and of course maintain. Do all the patching. StarWind simplifies the networking infrastructure and cuts unnecessary cost. We eliminate the need for dedicated switches. Our cluster backbone is built on directly connected 25 or 50 gigabit RDMA NICs, and any cluster up to 400 cameras doesn't require dedicated backbone switches. Traditional HCI storage is designed for multiple small applications working with small data sets. It's not designed to deliver consistent performance for one application working with the entire capacity of the cluster, like VMS. It's also not designed to satisfy both performance and capacity at the same time. So it's either fast flash with small capacity or large HDDs with less performance. StarWind changes this. We land all recordings on fault-tolerant flash for performance, uptime, and 0 frame loss. We then destage these recordings to HDDs for long-term retention. This combines performance, reliability, and capacity the way VMS needs it. Fault-tolerant flash also enables best performance for any other applications running on the system. The administrator managing the traditional HCI has to be trained in hypervisor, storage, network, clustering, and backup. Having such a professional in each edge location is nearly impossible. With StarWind, the administrator simply needs to provide how many resources are needed and what is the uptime requirement. We will handle where to assign these resources, how to replicate them, and how frequently shall the system be backed up. This allows organizations to manage lots of locations with minimum training and minimum staff possible. And last, traditional HCIs are designed to support all workloads equally. That means equally okay. This dictates a certain CPU to RAM to storage ratio that may not necessarily be the best for video surveillance workloads. Typically, we see less storage than the system needs and much more CPU and RAM. StarWind takes a different approach here. We size our systems based on number of cameras, retention, and analytic requirements. This results in a system that has the exact amount of resources in minimum possible hardware footprint, and as a result is more cost efficient and performs better. StarWind HCA for video surveillance and analytics is available on either Dell OEM or Supermicro OEM servers. That means great support and service and very reliable platforms. We work with both vSphere and Hyper-V, so depending on your preference or your requirements, we can support you in both vectors. We certified our systems with Milestone, Genetec, and we have an extensive experience of deployment with Bosch security systems since 2016. Storage and compute fault tolerance are paramount for video surveillance applications. Some deployments do not allow for any downtime at all. So we think that instant failover and uptime are things that you cannot exclude from this system. Proactive premium support is another thing that comes with StarWind systems by default. We monitor all the components and their vitals and make sure that if something is about to go wrong, the system informs our support team and we can prevent the issue rather than dealing with the consequences. Let's look at the solution architecture to better understand how everything works. We've got 2 or more StarWind HCA nodes that are connected via 25 gig or 50 gig RDMA Ethernet. The nodes run either Hyper-V or vSphere hypervisor and StarWind software-defined storage engine. StarWind manages the internal storage of the systems and presents it to the applications as a single fault-tolerant resource pool. In the hypervisor, users can deploy all the applications required for the project, including the VMS, its databases, Active Directory, access control applications, analytics, and others. There is also room for more applications or to scale the existing ones if requirements grow. All this is connected to the IP cameras, locks, sensors, and all the other equipment it's controlling via the existing networking. The video from the cameras is written to a fault-tolerant flash storage pool that's replicated between the StarWind nodes in real time. The storage pool is designed to hold up to 4 days of footage. After that, the footage is destaged to either local or dedicated storage pool comprised of high-capacity spinning disks, where it's stored until it can be erased according to the retention requirements. Let's look at how StarWind tolerates hardware failures. A typical 2-node cluster can obviously survive a drive failure. We can also survive a node failure. Nothing will happen. The applications will fail over to the remaining node and continue operating. The data will be intact. Next, in a 2-node cluster, we can also survive if we lose a drive and then all of a sudden we lose the second node. We have enough resiliency to survive this situation and the applications will continue running and the cameras will continue recording. If we go beyond that and add more nodes to the cluster, that allows us to go even further. StarWind server can sustain a simultaneous failure of 2 servers and 1 drive and still remain operational. Now let's look at how StarWind handles adding individual components as well as adding more nodes to the cluster. All StarWind systems support adding more drives, more RAM, as well as more interface cards or GPUs. You can also scale your storage further by adding an external drive enclosure that will be managed by the StarWind cluster. This allows customers to extend the video retention time without having to add more nodes or third-party storage products. If customer requires to add more cameras or analytic capabilities, StarWind cluster can support it by scaling out horizontally. This way we add more compute resources and storage capacity at the same time. When scaling, StarWind forms a grid. This is the most resilient scaling configuration as it allows us to maintain the required uptime level as well as guarantee consistent performance for all applications working in the cluster. While traditional HCI clusters fail if losing 3 or 4 nodes out of the entire cluster, StarWind supports losing much more than that. Even if we lose more than 50% of the nodes, the remaining nodes can still support your infrastructure, even though you will need to restore some of the information from the failed nodes from backup. This allows us to support mission-critical infrastructures in the event of catastrophic failures or extended outages. Managing such a complex infrastructure would be impossible without a centralized user interface. And StarWind Command Center is the tool exclusively designed for that. We provide a very simple way to manage each and every component of your cluster without having to dive into all the details and their interconnections. When provisioning resources for your application, StarWind will automatically pick how we replicate the storage, which nodes of the cluster we use, and what interfaces we want to use, as well as how frequently should we back up the system. We also support customizing Command Center for partners who would like to deliver a branded product with customized user interface specific for their clients. To give you confidence and peace of mind, we build our systems for maximum performance and reliability. We worked with the leading VMS and analytics vendors to make sure that all the components are sized and configured according to their best practices. We have certified the systems with Milestone and Genetec. We have used our previous experience of deploying Bosch security systems worldwide. We also continuously test and certify our systems with the leading hypervisor, operating system, and backup solution to ensure that all parts of the solutions work together flawlessly. This way, customers can be certain that the solution is supported by all participating parties end to end, and there is never finger pointing in case of any issue. Building a video surveillance solution with StarWind is 3 easy steps. First, pick your base model. Choose either one of the 18 ready bill of materials for various numbers of cameras, retention time, and analytics requirements. Or if those don't fit your requirements, we can get you a fully customized offer specifically tailored to your needs. Then see what you need to customize. For longer retention time, we can plan for drop-in capacity kits. For supporting more cameras in the future, we can either add extra nodes or leave slots for more CPUs down the road. For more analytics requirements, we can either add GPUs or GPU nodes. And don't forget that our engineering team is there to help you build the solution you need faster. We can help with all the aspects of the hyper-converged appliance deployment. And finally, we can help you deliver the solution locally to any customer location worldwide with the help of our global network of integration centers. A fun fact, with the help of our partners, right now 9 out of 10 busiest US airports rely on StarWind solutions for security and luggage. Transportation is not the only vertical that relies on StarWind solutions. High tech, media and entertainment, automotive, and hospitality also rely a lot on StarWind HCAs. And before we wrap up, just wanted to mention that there is more than just hyper-converged appliance from StarWind in the security space. We also have the software-defined storage engine, StarWind Virtual SAN, available for those organizations who already have their servers deployed, but want to virtualize storage and get more uptime and performance from their existing infrastructure. And we also have a virtual tape library that enables you to create ransomware immune copies of your data and send them anywhere, be it public cloud, on-premises object storage, or external media. With that, I would like to wrap up and thank everyone for joining us today. If you have any questions, feel free to reach out to sales@starwind.com or directly to me at max@starwind.com. Thank you and have a great day. Bye-bye.